Let us see the first example. Say, suppose this is your training corpus, which is having multiple sentences like this. Thank you for your help. I really appreciate your help. Excuse me, do you know what time it is? I really like you. I really like your watch. So these are the 5 sentences. And now, first step is you need to build an vocabulary or derive vocabulary from this corpus. So vocabulary contains individual words in the sentence. So see, this is how you can derive the vocabulary. Thank you for your help, right? So they you can write them as individual words, and you need to write only single occurrence of a word. Say suppose this your help, it occurred twice in the corpus. So no need to write 2 times. You can just write it only once. That is your help. And after that, I really appreciate, excuse me. So in this way, I really like. So it appeared again twice. So you'll just write only once and build the corpus or build the vocabulary. And now we are going to, we are giving the model an input, and we want the model to predict what can be the next word in the given sentence. So out of these 5 sentences, so we considered I really as input, and we want the model to predict next word in the sentence. So here you can see 3 sentences begins with I really. So among these 3 sentences, model should predict. So what can be the next word? Is it appreciate or like? So that prediction can be done like this. So here I'm using trigram representation. So first take like and check this is WI according to our notation. And these are 2 previous words, right? So when WI depends on previous 2 words, that is nothing but trigram representation, right? So this can be written as count of WI minus 2, comma WI minus 1, comma WI. So the given sentences, I really like. You have sentence like this, I really like. So in here, I really is the given input. So that means here I want to predict this WI. This becomes WI minus 1 and I becomes WI minus 2. So here count of WI minus 2, WI minus 1, WI and divided by WI minus 2 comma WI minus 1. So that you need to find out how many number of times I really like occurred together. So if you observe the corpus, there you can find out I really like it occurred twice in the corpus. So you need to write this as 2. And check how many times we have I really appeared together in the denominator. So appeared together in the corpus. So I really, it appeared 3 times. So just take only 2 words. So you can observe I really occurred thrice in the corpus. So divide, so that value will be 3. So this gives you 0.67. So 0.67 means 67% of the times like will be the next word after the words I really. So that is the probability value. In the same way, the other sentence, so the 2 out of 3 sentences which are beginning with I really. So 2 sentences starts with I really like, whereas the next sentence starts with I really appreciate. So you need to find out probability for both the sentences. So just now we have done with like. So now find out probability for appreciate also, just like how we did before. So in the corpus you can find I really appreciate occurred only once. So that value becomes 1 divided by I really. So it occurred thrice. So that value will be 3. It gives you 0.33. That is 33% of the times appreciate will be the next word after the words I really. So in this way, you can find out probability for the complete vocabulary for input I really. So this is the probability for all the words present in the vocabulary, and you can see all values are 0 except appreciate and like. Among these two words, as like is having more probability, we can say that the next probable word will be 0.67. That is, next probable word is like. Okay, let us take a second example. Her name is Siri. So this is our corpus where we are having start of a sentence and end of a sentence. So start of a sentence is always represented like this, and this indicates end of a sentence. Okay. First step is you need to build vocabulary, right? So vocabulary, this table you can see words and number of times those words appeared in the corpus. So we'll take even start and end of a sentence also. So how many times start appeared? So it occurred 7 times, as we have 7 sentences. And end also it occurred 7 times. So that value is 7. And check how many times her is present in the corpus. So it appeared once. So like that will give total number of occurrences. See this is. So is appeared 6 times. 1, 2, 3, 4, 5 and 6. So that frequency is 6. So like that, you need to build the corpus along with the word. You need to build the vocabulary along with the word and frequency. Now, the first thing is, so let us try to find out or give the modal input as start of the sentence followed by she. So now the modal should predict next word. So let us see how it predicts the next word. So here wi minus 1 becomes she. The previous word is she. So based on that word, model should predict next word in the sentence. So this becomes wi. So this is an example for bigram, right? So whenever a previous word is given, if you try to predict the word based on previous word only, then that is a bigram model. So the formula which we use here is bigram formula. We already saw how to derive this one. Now, so see this. Next word in probability. So first take all the words. So next word I'm taking it as end of a sentence, and the previous word as she. Because, so why not the start symbol here? So you can find out, so start indicates that's the first word in a sentence, right? So you can't take she before start. So no need to consider that. And end is, you will take end. So the previous word can be she. So check whether there is any, whether we have she at the, as the previous word of end. So there is no such sentence. So the probability will be 0 by 4. So 0. So what is, how we got this 4? So count of wi minus 1. Check how many times she appeared in the corpus. So how many times we have she? Once, 1, 2, 3 and 4. So it occurred 4 times. So divide the value by 4. Denominator will be 4. And then numerator. Numerator is, so we are predicting, or the model is predicting whether the next word is name. Given she. So check whether we have the sequence. She, comma, name. She name. So next word is, so here next word is wi. That is name. And the previous word is she. So you need to check this sequence. She name. So is there any she name? No, right? So that value becomes 0. Now check she is. Yes, she is existing in 3 sentences. So that probability becomes 3 by 4. And she Siri. No sequence. She. No. She intelligent. No. She topper. No. She good. No. She at no. She studies. No. She girl. No. So all these values are 0. Again, she like. Yes. So in place of CV or else, uh, this is not she, right? So this value also, let us take it as 0 only. And she chocolate, no sequence. Hope you understood this, right? So previous word wi minus 1 is she, and the next word which we are going to predict is wi. So I'm taking she as the previous sentence or previous word, and wi as next word, and we need to check that sequence. She, whether we have she name, she is, she Siri, like that. So in this example, what is the most probable word? Find out the values. So all the other sequences, they are having 0, whereas she is having value 3 by 4. We can say that next word, the most probable or the next word might be she is. It occurred 3 times in the document. So the next probable word might be is. In that way, Moodle will predict. Next up, she is good. So this is the input given to the model. And now model should predict next word. So if a model is predicting the word based on the previous 2 words, say suppose here the model is predicting next word based on previous 2 words. So that is the example for trigram, right? So take the formula for trigram. So wi minus 2. So this becomes wi minus 2, which is, and it becomes wi minus 1, good, and this is your word wi, which we want to predict now. The formula which we use for trigrams is, so here probability of wi given wi minus 2 and wi minus 1. So you can write it as count of wi minus 2, wi minus 1, and wi. So you need to take the sequence of words, and these are the given words. Is good. So first draw one table like this with next word in probability, just like the previous case. And now the sequence or the denominator is having 2 words, right? Wi minus 2 and wi minus 1. So what is wi minus 1? That is good. Wi minus 2 is. So I'm taking is good as denominator. And check how many times is good occurred in the sentences. And sequence should be is good only. It should not be good is. Okay. Check how many times we have these 2 words together. Is good once, is good twice, and that is 3. It occurred 3 times. So denominator value will be 3. And say suppose this is the word which we want to predict. So check how many times we have a sequence as is good end. So is good followed by end. There is no such sequence. So that value becomes 0. Next up. So this is good. So is good, next word, right? In numerator. So is good is. Is there any sentence? No. Then is good Siri? No. Is good she? No. Is good intelligent? No. Is good topper? No. Is good good? No. Is good at? Yes, we have a sentence is good at. So these are the previous two words and this is your next word. So here you can see that is good at. Probability is 2 by 3. So how we got 2 by 3 here? So is good occurred only once. So this value becomes 1 only. So that value is 1 by 3. Next, is good studies 0. Again, is good girl. So check is good girl. Yes, is good girl occurred once. So that value becomes 1 by 3. Is good like, no sequence. Is good chocolate, no sequence. So those values remain 0. Next, third example. So she is good girl. Now we want the model to predict next word based on previous 3 words. So this is the example for 4 gram. So take Wi minus 3. So this becomes Wi minus 3. It is Wi minus 2, Wi minus 1, and the word to be predicted is Wi. And this is a formula. Probability of Wi given Wi minus 1, Wi minus 3, I minus 2, I minus 1. So check how many times these 3 words occur together in the corpus and draw table. So denominator should be is good girl. So check how many times we have is good girl. It occurred 2 times. So denominator value should be 2. Next. Next word after is good girl. So is good girl followed by end. So it occurred once and here it is 2. So we are just taking these 3 words. No need to consider the previous one. So even though here we have Siri and it is she, as these words are same, we can take this probability as 2 by 2. Next, is good girl name. No such sequence. So 0. So like that, for all the remaining words, we can take the probability as 0 by 2 because there are no such sequences. So in this way, we'll predict the model will predict the next words. Then coming to various applications. So here the first application or first example is speech recognition. So this Ngram language model, it is used to predict the next word in a spoken sentence. So in that way, it is useful in speech recognition and machine translation. So here also it is used to predict the most likely translation of a sentence. So based on the given context, it will try to predict the most likely translation of sentence. Next, third one is text classification. So it is used to classify this language model. It can classify the given text document into different categories. So how this classification will be done based on the given content. And one more example is information retrieval. So in order to retrieve multiple documents based on the given query, so first this model is used to rank search results. So based on the ranking related, say there are 5 documents. So the document which is having the highest rank that will be displayed or that will be retrieved first. So like that, it is used to rank search results based on their relevance to the query. So the document which is more similar to the query, that will be ranked first, followed by second. Like that, documents will be retrieved one after the other based on their relevance to the query. So these are few applications.